My name is Jose Lopez. I'm part of Group 6, and this is question 4. In question 4 asks to arrange mutants in order that corresponds to the steps and pathways for processing N-linked oligosaccharides, and to assume each mutant is effective for a single enzyme only. In order to manufacture an oligosaccharide, it has to go through multiple steps, and each step is affected by different enzymes. We are looking to see where the deficiency is for a specific enzyme. In order to compare the mutants, we need to find the wild type, that is a oligosaccharide cycle without any mutations. In order to know what the wild type looks like, we look at this final image, and we also look at the data that's given to us. Within this column, it describes what molecules are within that form. So for mannose, that is the black hexagon. GLC-NAC, that is the white hexagon. Galactose, that is the light gray hexagon. Nana is the one with a dash in it, and glucose is the dark gray one. So if you look at wild type, there's 3 mannose, that's the black one, 1, 2, 3. GLC-NAC, there's 5 of them, that's the white one, 1, 2, 3, 4, 5. Galactose, that is the light gray, there's 3 of them, 1, 2, 3. Nana, that's the dash, 3 of them, 1, 2, 3. Glucose, there's none, so there should be none here, and there is none. So I won't go through all these mutants and describe how to find them, but we'll start with mutant A to give an example. So mutant A, we look at the first column, that is mannose, and so it says here there's 5 of them. So we have 2 options here. We have, let's call it option A. There's 1, 2, 3, 4, 5 mannose, check. And option B, 1, 2, 3, 4, 5 mannose, check. Now we go to the next column, GLC-NAC, there's 3, that's the white one. Option A only has 2, so X, but option B has 3, 1, 2, 3, check. We are not going to assume that the rest is complete. We should also check the rest of the molecules. Galactose, 0, that is the light gray one. There's 0. Nana, that's the dash, 0, 0. Glucose, 0, 0. So mutant A, the final form, is in between step 3 and 4. However, in order for mutant A to progress, this enzyme needs to affect the final form in order to go to the next step. However, since there is a deficiency, the enzyme does not work as intended. Therefore, this is the enzyme that has a deficiency, and mutant A has a Golgi mannose 2 deficiency. So to look at the order, we'll go to this next slide. I'm not going to go back and forth and describe like that. I'm just going to read it off this chart. So we kind of went through each number, each step. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and within it, for example, in the first step, we did it in the order that it tells us. However, in mutant 5, in step 5, there's not really a specific order, so this is the exception to our reasoning. So first step, mutant D is affected by glucosidase 1. Mutant H is affected by glucosidase 2. And mutant G is affected by ER mannose. And we go to step 2. Step 2 is affected, and mutant C is affected by step 2 of Golgi mannose 1. And step 3, we look at GLC-NAC transferase 1 is the deficient enzyme in mutant E. Step 4, mutant A has Golgi mannose 2 as the deficiency. As I said before, step 5, there's not really a specific order, so we just went top to bottom. Mutant I has a deficiency in GLC-NAC transferase 2. Mutant B has a galactose transferase deficiency, and mutant F has a nana transferase deficiency. Thank you.